Assalamualaikum and hi everyone. Today my team members and I are going to present our video which is about mini portable fan. Mini portable fans function based on fundamental principles of thermophysics, primarily enhancing heat transfer through forced convection and accelerated evaporation. They do not technically lower the ambient temperature of a room, but rather make human skin feel colder by breaking down the insulated boundary layer of. Okay, so these are some of our target users. For students, it fits perfectly inside backpacks, keeping you focused during hot and long exam seasons. For office workers, it is very compact and ultra silent, so it helps you beat stuffy office cubicles without disturbing your coworkers. For babies, it had gentle whisper quiet airflow, keeping the infant cool and safe without waking them up or disturbing them. For athletes, it provides instant high power cooling, and it also accelerates muscle recovery and lower core body temperature post-workout. With hikers in mind, we also have a feature of a red clip-on design. It helps them to keep their hands free so that they can keep cool while going through the toughest uphill trails. Campers can also use them because they're lightweight with a massive battery storage, keeping their tents breezy throughout the night.
Now, I will be talking about components and mechanisms of our mini portable fan. To start with aerodynamics, the blades are designed to pull in air and create a high volume, low pressure flow to create a strong focused airflow. Next, for the motor, it converts stored battery energy into kinetic energy that spins the blades. The motor also applies torque to rotate the blades, producing angular velocity that generates airflow. Speed control is also available, where multiple speed settings allow users to balance cooling performance and battery consumption. For semiconductor cooling, thermoelectric cooler (TEC) is used on certain models, which creates a temperature difference. One side becomes cool while the opposite side releases heat, producing a cooling surface that lowers the air temperature of the airflow. Lastly, for battery power, our mini portable fan is typically powered by rechargeable lithium-ion batteries.
Moving on to how we power this device, let's talk about the battery system. At its core, the fan uses a standard 18060 size lithium-ion rechargeable battery, chosen specifically for its lightweight portability and high energy density. But high energy density requires smart management. That's why we've integrated a battery management system or BMS alongside a dedicated protection circuit. Together, these act as a tiny on-board computer that actively prevents dangerous overcharging, over-discharging, and overheating. Essentially, guaranteeing this device remains completely safe from fire hazards. For performance and daily use, we utilize pulse width modulation or PWM power regulation. This quickly switches power on and off to efficiently adjust the motor speed between low, medium, and high without wasting energy. When it's time to top up, the system easily converts standard 5-volt USB power to safely charge that internal cell. Now, let's talk about the physics behind moving the air, the angular mechanisms. First, we have the blade pitch, meaning the blades are intentionally molded at a tilted angle. When they spin, this specific slant scoops up the quiet air and pushes it straight forward. This is paired with a curved design on the blades themselves, which allows them to scoop up a larger volume of air smoothly. This aerodynamic curve does two things. It reduces chop and noise and saves battery power by reducing drag.
Now, we will discuss the core thermophysics principles involved in a mini portable fan. The first principle is convection. The fan moves air, replacing warm air in contact with skin with cooler air, increasing the rate of heat transfer away from the body. Another important principle is evaporation enhancement. The airflow increases the rate of sweat evaporation from the skin, and since evaporation requires energy, this latent heat is absorbed from the skin, resulting in a cooling effect. A mini portable fan also applies boundary layer removal, where stagnant air acts as an insulating layer. The moving air from the fan disrupts this layer, allowing for faster heat exchange. Lastly, humidity management. By keeping air in motion, the fan moves humid air away from the skin, preventing saturated air from restricting the body's natural cooling processes.
Next, I will explain the key performance factors of our mini portable fan and how they relate to physics concepts. First is the wind chill effect. Portable fans help us feel cooler by increasing heat loss from our screen through convection and evaporation. Even though the air temperature stays the same, the moving air remove heat from our body faster, making us feel more comfortable, especially in hot weather below 35 degrees Celsius. Second is acoustic performance. Our portable fan uses a brushless DC motor, also known as a BLDC motor. This type of motor produces less friction and vibration, which make the fan quieter. In physics, less friction means less energy is wasted as heat and sound, making the fan more energy efficient and durable. Third is runtime per chain. The battery life depends on the fan speed. At low speed, the fan can operate for around 10 to 20 hours, while at high speed, it lasts for about 3 to 5 hours. This is because higher speed requires more electrical energy and power consumption, causing the battery to drain faster. Lastly, rotational speed or RPM, which stands for rotations per minute. A higher RPM means the fan blades rotate faster, producing stronger airflow and better cooling performance. This concept is related to rotational motion and kinetic energy in physics. In conclusion, our mini portable fan is not only convenient and portable, but it also applies important physics concepts such as heat transfer, energy efficiency, rotational motion, and airflow to improve cooling temperature.
Lastly, there are three important considerations about this product. First, ensure portability. The mini portable fan has a compact structure and low mass improve the mobility of the mini portable fan, which is constructed using lightweight and durable plastic materials, which reduce overall weight while maintaining structural strength. Second, energy efficiency. Power consumption is reduced by using a low wattage DC motor. The mini fan also has a high capacity lithium-ion rechargeable battery used to supply electrical energy, this allowing longer operating time while maintaining stable performance. Third, airflow efficiency. A high-speed DC motor with a rotational speed exceeding 5,000 revolutions per minute is combined with an aerodynamic blade designed to improve airflow smoothness and efficiency. This is resulting in more efficient cooling performance. In conclusion, these considerations ensure that the mini portable fan is efficient, portable, and effective in delivering airflow based on key physics principles such as energy transfer, motion, and fluid dynamics.
In conclusion, a handheld fan works by applying thermal physics principles such as force convection, evaporation enhancement, and boundary layer removal to help cool the body more efficiently. Its motor power blades create airflow that increase heat transfer and sweat evaporation, improving comfort in warm weather or conditions. Features like aerodynamic blade design, rechargeable batteries, and brushless motors enhance performance and efficiency. However, handheld fans are most effective at moderate temperatures and may become less useful in extreme hot environments or weathers.